Let's tackle Leetcode problem 3542, minimum operations to convert all elements to zero. Here's what we're dealing with. You have an array of non-negative integers, and your goal is to make every element zero. The operation allowed is quite specific. You select any subarray, find the minimum non-negative value within that subarray, and set all occurrences of that minimum to zero throughout the subarray. The question asks, what's the minimum number of operations needed? For example, if you have array 2, 1, 3, 1, you could select the whole array, find minimum 1, and zero out both ones. Understanding this operation rule is crucial to solving the problem efficiently. The breakthrough insight is recognizing that we need to count strictly increasing subsequences in our array. Why? Think about it. When we perform an operation on a subarray, we remove its minimum value. Elements that are strictly increasing from left to right will require separate operations because each one will be the minimum in its own context at some point. For instance, in array 1, 2, 3, we need 3 operations. First remove 1, then 2 becomes the new minimum requiring another operation, then finally 3. However, if values decrease or stay equal, we can handle multiple elements in fewer operations. This transforms our problem into counting increases. The elegant solution is remarkably simple. Iterate through the array and count how many times a value is strictly greater than its predecessor. Start by initializing your operation count to 1 for the first element. Then, for each subsequent element, if it's greater than the previous element, increment the operation counter. If it's less than or equal, no increment is needed. For example, array 3, 2, 1, 2, 1 would give us 2 operations, 1 for initial 3, and 1 more when 2 follows 1, creating an increase. This works because each increase represents a new level we must handle separately. Let's understand why this algorithm is correct. When values decrease or stay flat, we can eliminate them together with previous elements in the same operation because they won't be the minimum in their context. However, when a value increases, it cannot be eliminated alongside the previous smaller value. It will remain after the smaller value is zeroed out, requiring its own operation. Think of it like peeling layers. Each strictly increasing step adds another layer we must peel. The number of these increasing transitions plus the initial layer equals our minimum operations. This gives us an optimal linear time solution with O(n) complexity. Let's walk through array 5, 3, 3, 6, 2, 1. Start with operations equals 1 for the first element 5, moving to 3. It's less than 5, so no increase. Operations stay 1. Next 3 equals previous 3, no increase. Then 6 is greater than 3. This is an increase, so operations becomes 2. Then 2 is less than 6, no change. Finally, 1 is less than 2, no change. Total, 2 operations. We can verify this makes sense because we essentially have 2 peaks or increasing levels to handle separately, making this the minimum possible operations needed.